pleasant wisdom learners. This is Sir Peter, your statistics and probability teacher. So we are now done with the 3 video lessons for weeks 3 to 4. Let us now proceed to the fourth one, which is the application of normal distribution. So at this end of the video lesson, you should be able to solve different word problems involving the applications of normal distribution in real life. So let's have this example problem. Are you now ready to solve problems? So this is our situation. In a certain forest, the population of wild rabbits is 1,000. Their average length is 30 centimeters, and the standard deviation is 4 centimeters. Suppose that the population is normally distributed. The first question, what is the probability that a rabbit picked at random has a length shorter than 24 centimeters? Letter B, how many rabbits are shorter than 24 centimeters? And for letter C, how many rabbits belong to the lower 33%? So, notice that the total population of rabbits is capital N, which is 1,000. Our average length is represented by mu, so that is 30. And our standard deviation is 4, so that is sigma, which is equal to 4. So this given will be repeated as we solve each problem. So let's answer the first question. So what is the probability that a rabbit is picked at random and has a length shorter than 24 centimeters? So again, our mu is 30, our standard deviation sigma is 4, and the population size is 1,000. So that's our given. Next, step 1. We convert the raw score x is equal to 24 into a standard score z. So how do we convert that? We use the formula z is equal to the raw score minus the mu or the mean over sigma. So our x value is 24. Our mean or mu is 30, and the standard deviation is 4. So we'll have 24 minus 30 divided by 4. So that will be equal to negative 1.5. So determine the probability that z is less than negative 1.5. So why did we use a less than symbol in the probability notation? That is because of the word shorter than. So the probability that z is less than negative 1.5 is 0.5 minus 0.4332. So you have to look on the area using the z table. So that will be 0.0668. So how does it look like in the graph? So look at this one. So from 0, and next we locate the vertical line representing negative 1.5, and the required area is less than. So this is the shaded area. So to get the total area, we need to subtract 0.5 from the area from 0 to 1.5, which is 0.4332, so that we will get 0.06868. Okay, so thus the probability that a rabbit picked at random has a length shorter than 24 centimeters is 0.0668, or when we move to decimals to the right, the probability is 6.68%. Next, how many rabbits are shorter than 24 centimeters? So what we're going to do is to get the probability. Again, the probability is 0.0068. And to determine the total number of quantity, we simply multiply it by our capital N, which is the population size. Okay, so the number of rabbits is equal to the probability times the population size. So 0.0668 times the 1,000 rabbits. So all in all, there is 66.8. So we round it up because there is no 0.8 rabbit. So instead, we consider that there are 67 rabbits which are shorter than 24 centimeters. So that is a practical application of normal distribution. So thus, there are 67 rabbits that are shorter than 24 centimeters. Now let's answer how many rabbits belong to the lower 33%. So we will be applying here the percentile. So first, we determine the quantity. The number of rabbits is equal to the probability times the total population. So the probability is 0.33 times 1,000. Of course, there will be moving 3 decimal places. There will be 330 rabbits. So thus, there are 330 rabbits that belong to the lower 33% of the population in terms of their length. So if you want to determine the quantity of rabbits or a quantity from a given total population, you simply multiply it by the probability which is obtained from the areas under the normal curve. So it is very important that we know how to transform a raw score into a standard score. And from the standard score, it will give us an area under the normal curve. And that area will give us a probability. And multiplying it by the total population will give us the exact quantity of values which are either lower or greater than a certain standard score. So that is just one of the practical applications of normal distributions in the real world. So on the next video lesson, this will be the last, you will be able to learn how to locate percentiles under the normal curve. So see you then. Again, this is Sir Peter, your statistics and probability teacher.